Yeah, welcome. Let us have a discussion on the Kubernetes architecture. So if you see the architecture of the Kubernetes, you'll be having Kubernetes master machine followed by the workers. Okay, there's a confusion among many regarding the components which are forming part of the master and the worker. So let us have a clarity on this so that later when you start diving deep into the Kubernetes, it will be easy for you to understand Kubernetes. So among all these components of the master or the node, so let us first start talking about Docker, and then container, and then pod. So the components what I'm going to discuss for the worker node 1 will be equally be applicable to the worker node 2. Clear? So if you see worker node 1, the actual components are nothing but the Docker, kubelet and kubeproxy. So before dealing with these components, let us have a clarity on Docker, container and pod. So if you have clarity on these three, then you'll never forget this architecture. It will be an easy for you to understand. Okay, now let us start with. So let us start with the container and Docker. Okay, now for example, where and all have you come across containers? So in your real life, if you can see, in your kitchen you have containers. Okay, so you'll have containers for your sugar, a separate container for rice, a separate container for salt, a separate container for turmeric. So the purpose of containers is to containerize the environment and not to mess up the environment in container A with the environment in container B. Okay, now you can compare the containers with your individual lunch boxes also if you want. For example, if you are carrying a lunch box, you can have container for bread, container for rice, container for snacks, and you can also carry water in a separate bottle or container. So at the end, container means to containerize the environment. Okay. So in this scenario of Kubernetes, containers are nothing but deployable application. They hold specific environment. Okay, now inside the container, what is that you'll be having? You'll be having an application inside the container. Okay, so straight away you'll not have an application as it is. The application is converted into an image, and that image will be running inside the container. So creating the application as an image is a separate and a challenging task in a real time, but that's entirely a different thing which we have to have separate hands-on and learn in deep. Now coming back to the Kubernetes architecture and the containers, if you see, when a container is running, nothing but the application which you have converted into an image will be running inside the container. So when an application is running, obviously the application will you'll take the help of the resources. So usually what are the major resources it will take? Nothing but the RAM and CPU. So inside the container, when the application is running, it will be taking the help of RAM and CPU. So from where are the RAM and CPU being utilized? So it is nothing but from the host machine, the RAM and CPU are utilized. Clear? So usually there will be only one underlying host machine to run containers. So if someone asks you how many containers can be created, it depends on the capacity of the host machine, because inside the container, when an application is running, the application will utilize the host machine resources. So automatically how many containers can be created, it will depend on the capacity of the host machine or the underlying host machine. Okay, clear till here? Now, so what will be usually inside an image? As I said, the application will be converted into an image and it will be running inside the container. But inside the image, not just the application, but you will also have libraries, binaries, and also operating system. Usually images are said lightweight. The reason is it will have an operating system without a kernel. So the question is, from where the kernel will be used? The kernel will be used from the host machine. So this is how container works. So as said, containers will take support of the host machine's hard disk and RAM. Only then the containers will start running. Now RAM and hard disk are used only when the container is running. If the container is not running, obviously the RAM and hard disk are left back to the host machine. So RAM and hard disk will be unutilized when a container is stopped. If container is not running, as said, the RAM and hard disk are not used. Container will hold application inside it. So only if application is running, then only it is said as container is running. So with this background of container, so now you should have come to an understanding why do you require Docker as one of the component for this worker node. So it is obvious that without Docker you cannot create container. So all the creation of the container, start, stop, destroying the container, all this is done, and it is possible with the help of the component called Docker. So I hope you are clear with this concept of the component called Docker, and followed by the background what I have given for the container. Now let us go with the understanding on this component called pod. Actually, pod is not a main component. In a node, the main components are nothing but Docker, kubelet and kubeproxy. But let us also have a clarity on pod, so that you'll have a clear understanding what is pod, what is container, so the difference between a pod and a container, so that once the clarity is obtained, it will be easy for you to understand deep in Kubernetes. So now in Kubernetes, what is that we'll be creating is nothing but the pod. Okay, so what is a pod now? So technically it is said as pod is an object. Okay, this will not be an easy to understand. So let us compare it to a layman example. So as I said, containers are nothing but your lunch boxes. Okay, but pod is nothing but your lunch bag. What is pod? Pod is nothing but your lunch bag. If pod is your lunch bag, container is your lunch box. So for example, if you are carrying a lunch bag, or if you are carrying lunch to your office, is it that you will be carrying one lunch box in one hand which is having rice, another lunch box with bread in another hand, and water bottle in your bag? It is not the case. So if someone is saying carry lunch, if your parents or if you are telling your children to carry lunch, it does not mean to carry each lunch container separately. It means that they have to carry lunch bag right? So I mean to tell, if pod is a lunch bag, containers are your lunch boxes. So if you carry the bag, automatically the boxes will also flow with the bag. So with this background, I hope you understand the difference between lunch bag and lunch boxes. So pod will be your lunch bag and the containers are your lunch boxes. Clear? So whenever you say deployment, it is not about creating the container. Your container will be actually running inside a box, and that box is called pods. Your Kubernetes will be managing the box, and inside the box called pod, container will be running. So going forward, if you want to create a container, you will not say create a container, but you will say create the object of the type pods. Okay. Now because Kubernetes manages the pod, and inside the pod your container will be created, or inside the pod your container will be running. So you will not tell Kubernetes to create the container, but you will tell to create a pod. Why do you need a pod? Can't I run the container directly? So the answer is, as we discussed, for lunch there are few supporting things needed, like you require, when you are carrying a lunch bag, apart from the lunch boxes, so if you have one box with rice, one box with bread and one box with snack, if you carry these 3 containers, is it sufficient? No. It requires a napkin, it requires a spoon, and it also requires some other supporting things. So the same way, there are some supporting things needed for the container, so that everything we will put together into a bag, which is nothing but pod. So pod is a layer, and inside the layer called pod, you will be having your container running. By default, for every pod there will be one container. So understand, by default for every pod there will be at least one container. Every pod will have a unique IP address. So when your application is running inside the container, nothing but it is running inside the pod. So to access your application which is running inside the pod, which means which is running inside the container, you should access the pod IP address. So every pod will have a unique IP address. If you want to communicate with a container or an application running inside a container, then you are going to access the pod, and the pod will redirect to the container, and inside the container you will be having your application running. In Kubernetes, anything that you are going to start, stop is nothing but the pod. So you will start the pod, you will stop the pod, and inside the pod you will have the container. Now if you have, I think you might have heard something called replicas in Kubernetes. Okay, so if your requirement is to have 2 replicas of the container, okay, if you want to have 2 replicas of the container, then Kubernetes, what it will do is, it will create 2 pods. Getting the point? And there is something called scaling also. So whatever that you want to scale in Kubernetes, you will be scaling the pod. Okay. For example, if you say, if you have an application like a Facebook application, and you want to create 6 containers or 6 replicas, then Kubernetes will create 6 separate pods, and in each of the pod there will be one container running. So Kubernetes will be finding the machine capacity in which pods have to be created, depending on which, or depending on the resources that you have given. So if I tell I want 4 GB to create a container. It is not the container, but it is the pod that Kubernetes will be creating. So Kubernetes will go and check which worker node has got 4 GB of resources available. So that 4 GB can be either a RAM or a CPU, or it can be a combination. So what Kubernetes will do, it will go to the worker node and check which machine has got that 4 GB of capacity, and based on the availability, if worker node 2 is having the capacity of 4 GB available, then in this worker node 2, pod will get created, and in the pod containers will be made available. And last but not the least, you cannot have a logic like pod on one machine and pod on one machine and the container in another machine. That is never possible.